So next one is optocouplers. So optocouplers is a very important device. So it is a device in which the light emitter, the light path, and light detector are all enclosed within the component and cannot be changed externally. So it is going to be an isolation. I'm going to this device will have three parts. One is the light emitter source. One is the path through which the light is traveling, medium, and third one is the light detector. Okay, it is going to be the destination. So source, medium, and destination all are in the same device, but they are properly isolated. Okay, so an optocoupler provides isolation between circuits, so it is called as an opto-isolator. An opto-isolator also allows signal transfer without coupling wires, capacitors, or transformers. So circuit is going to isolate different portions of your circuit for safety. So if you feel that different components of a circuit can interfere and cause damage, you can put an optocoupler between those different stages to prevent damage to each and every portion of the system. Okay, so it can couple on or off signal accordingly. Since it is going to work based on light, whenever there is light, it is going to be on. Whenever it does not emit light, it is going to be considered to be off. So you see here, so you have an input signal. I give the input here to the system. I give the input here, and that input is given to an LED. And in the receiver, I'll be having a photo detector. So the light coming out of the LED will fall on the photo detector, and I'll be getting the output signal, which is proportional to my input. And you can see this portion of the circuit is isolated. So this is the medium. This is source, medium, and your detector are isolated. They will not interfere. See, electrical transmit பண்ணும்போது, when you transmit the signal same as voltage or current, the interference will be there. But here you see I'm converting the signal from electrical to optical, and I'm converting it back from optical to electrical. So I am going to provide isolation in this manner. So an optocoupler or an opto isolator will have three components. One is LED, and another one is a pin photodiode. Okay, and I am going to have air as the medium for light to travel between the LED and photodetector. So you can also have optical fiber cable between them if it is long distance. But since the LED and photodetector are very close to each other, I am not going to connect any medium for them, and the light coming out of LED will directly fall on the PD photodetector, and it will produce the equivalent electrical. So output signal will be proportional to input. கண்டிப்பா அவுட்புட் வந்து ஈக்குவலா இருக்காது, பிகாஸ் யூ வில் ஹாவ் சம் அமௌண்ட் ஆஃப் லாஸ். அவுட்புட் வில் பி ஆல்வேஸ் லெஸ் தேன் த இன்புட், பட் ஐ கேன் சே அவுட்புட் இஸ் ஆல்வேஸ் ப்ரொபோர்ஷனல் டு யுவர் இன்புட் சிக்னல். Okay, and instead of photo detector, I can use in photo detector I have two things. I can use PD and PT, photo diode and photo transistors, right? So depending on whether I need more current, I can either go for photodiode, pin photodiode I can use, or photo transistor I can use, or Darlington pair transistor I can use, or I can use photo SCR. So we have seen light activated SCR, right? We can also use that here. So instead of having a detector, I can use a photodiode or a PT or a light activated LASCR. So I can use any one device as the photo detector unit. So they convert the input voltage into proportional light intensity. So how much amount of input you are giving, that much intensity of light is produced by the LED. It is emitted as the light from the LED. So the light is converted back into the electrical signal using the detectors. And detectors and sources are all made up of gallium arsenide, because I told you silicon and germanium cannot produce light. All light producing and light detecting materials predominantly are made up of gallium arsenide. So you see here the LED is made up of a gallium arsenide, and it is going to provide the required intensity of light to the photodetector. Photodetector is made up of silicon, so the wavelength of operation of this light LED and the detector should be same. So if the LED is emitting light in one color, PD is working in a different lambda, then the system will collapse. It will not work. So these two, the source and the detector, should be working in the same wavelength. That is the condition you have to have. See here, the wavelength response of each device has to be identical so that maximum coupling is possible. So if you don't connect the devices properly, or if you don't configure the source and detector properly, then the device will not work and you will not have coupling possible between the devices. See, this optocoupler is based on how effectively you're going to couple light from LED to the detector, right? So that coupling is perfect, or it is maximum only when the LED and the detector are working in the same wavelength. So only when these two are working on the same wavelength, you can ensure that the coupling is maximum. Otherwise, you cannot expect the optocoupler to work properly.